Hello everyone, welcome to my YouTube channel. So in this particular session, we will talk about the implementation of ternary search. Yes, the same implementation thing, that concept which we already discussed in our previous session, right? So the main prerequisite to understand this particular session is that you should have the understanding of the conceptual part that I have already discussed in my previous video. So those who are not aware about what is ternary search and what is the major difference between the ternary search and the binary search, first of all try to grab that concept from the previous video of mine and then only come towards this implementation part. Okay, so let's get started. So whatsoever concept we have discussed in our previous session, that concept we need to implement in today's session, because only conceptual understanding is not enough. So in all the YouTube series of whatsoever I will discuss, I will show you first of all the conceptual part, and then after that the implementation for the same, because this is what you will see in practical life scenarios as well, that if you know something conceptually and you don't know how to implement that, that is of no use, right? We need to see how basically whatsoever concept we have studied so far, we can apply in our practical coding part. Now what I will do is that first of all I will write the driver code, where I will take the same kind of array that we have discussed in our previous session. For example, 2 4 6 8 10 10 and suppose 12. So this is the array that we have. What is the key that you are looking for? Suppose I am looking for a key named 6. Now what I will do is that I will try to store my result in a function named ternary search. In a function named ternary search, which will take the array, which will take the starting index, which I will say as a left, which will take the ending index, which is nothing but the length of the array minus 1, because I hope everyone is aware about the concept that array index will start from 0 and will reach until the value of n minus 1. So that's why we have initialized it as n minus 1. After that we are passing the key. Now this is something which is what we are doing is the function calling here, right? We are calling the function which is responsible to do that particular ternary search which we have understood. So obviously we have to do the function definition here for the same ternary search, so that it will be able to understand, my code will be able to understand what is the meaning of this ternary search. So here we will pass array, we will pass the left index, we will pass the right index which is entered by the user, and the key. So these are the same things that we know. Now we need to pass that value of left is less than equals to right, because this is the condition that the left index value should be always either less than or equal to the value of the right. It should never be greater than the value of the right. If that is happening, it means you have covered entire array, right? So now the next point is we have to calculate what is the value of the mid one. This is something which is equals to left plus right minus the value of the left divided by 3. Why 3? We have already understood in our previous session that here we are doing ternary search, means we are dividing our array into 3 equal halves. Similarly, we are moving towards finding out the value of the mid 2, which is something equals to right minus the value of the right minus the value of the left divided by 3. Right? Now we are ready to check the conditions, right? If the value of the key is something which is equal to the value of the mid one, this is the base case condition. At that point of time, not mid one, the value of the heir of mid one. So at that point of time, I am pretty sure that give me the value of the mid one directly. Otherwise, it might happen that the value of the key is equal to the value of the heir of mid 2. So at that point of time, return me the value of the mid 2. Return me the value of the mid 2. Otherwise, what we can say, it might happen that the value of the key is less than the value of the heir of mid 1, is less than the value of the heir of mid 1. So in that particular scenario, I am pretty sure that it is a first case scenario, the first way that we have already discussed, right, in our classes. So here if you will see, this is the first thing, that first half that we need to explore at that point of time. So it means that we have to change the parameter on the right side. So it means what I will do is that I will do a recursive function call. What is the meaning of a recursive function call? Calling the same function again but with different set of parameters. So here what I will do is that I will say left will remain as it is, but the value of right will become mid1 minus 1, because I know that my element that I am looking for will present on the first half, right, whose range is starting from left to mid1 minus 1, and then I will pass the same key here as well. After that, again, it might happen that the key that I am looking for is greater than the value of the array of mid2. At that point of time, what I will return? I will return ternary search, but now the parameters will become, the value of left will get changed to the value of mid2 plus 1. The value of mid2 plus 1, because now I know that the element will be present at the extreme third half, right, this third half, whose range will be from mid 2 to right. So here I will change the left thing by mid 2 plus 1, right will remain as it is, and the key will also remain as it is. Now this is also not the case. At that point of time, I am sure that this is the second way where my element will be present to within that mid1 and mid2. So what I will do is that I will again call this function, but now the parameter will be mid1 plus 1, mid1 plus 1, mid2 minus 1, because that is the only range which is left if my if condition is lying under this range. And if suppose this is also not happening, if suppose this is also not happening, it means return the value as minus 1. Means the element that you are looking for is not at all present inside your array. Then obviously how it will show that particular key. So what we can do is that we can print this result. We can say that key index is present at the location, and here what we can do is that we can simply apply that result here. Let's try to see if there is any error, then we will see at that moment. So here it is showing to me the correct result, that key index is present at location 2, because here if you will see, this is the 0, 2 is present at 0th location, 4 is present at first location, 6 is present at the second location. If suppose what I will do is that I'll try to maybe change it to 12. Let's try to see now, is this giving, is this will give the correct answer? 5. So 0, 1, 2, 3, 4, 5. So yes, my 12th element is present at 5th index, right? Now if suppose I will say 14, suppose I will say 14. Now let's try to see. It is giving me that there is no as such location where that particular index is present. There is no as such location where there is an index 14 will be present. Similarly for 1 also, if you will see, there is nothing, any particular index where it can give me the result. For example, I'm mentioning 2. So these are the several kind of test cases which you can see from your end, right? Which you can see from your end. What should be the final result? Our whatever element will present at that point of time, we should give its valuable index. If it is not present, it will either return some statement also you can return that that particular element is not present, or it will return none, which indicates that okay, the element that you are looking for is not present inside the array. So this is the basic idea behind the ternary search that we have already understood in our previous session conceptually, but in today's session I am discussing it via implementation using Python programming language. Now you can do the same thing with any kind of programming language, whichever you feel is you are having a expertise. Now here if you will see, if I will talk about the recurrence relation of this particular implementation that I have written down here. So here if you will see, what we are trying to do is that either my code will go towards the first half or the second half or the third half. So here if you will see, this represents the first half that we have written in our documentation file. This particular path is representing the third half, which I have mentioning in my documentation file, and this particular path is representing somewhere the second half, right? So either my code is going towards first half or second half or third half. It can't go to all the paths, right? So the recurrence relation will be T of n, which is equals to T of n divided by 3, right? Plus how many if conditions are there? How many if conditions are there? 1, 2, 3, add 4 plus 4c, which is a constant one. So if you will try to solve this recurrence relation by using any method, for example, you can apply substitution method, right? Or you can apply Master's theorem as well. You will see that the time complexity that you are getting for this code is order of log of n, and here the base will be equal to 3. Now, if you will remember, whenever we are talking about binary search, we were getting the time complexity is order of log of n base 2. Why? Because there we are dividing our data into two parts, right? Either it is moving towards right or it is moving towards left. But here, because I am dividing my data into three halves, that's why you will see that the time complexity will be nothing but it's order of log of n base 3. Okay. Now, this is the very important thing that you have to understand. Apart from this, now we know what is binary search. Now we know what is ternary search. We can see the time complexity as well, right? What do you think? This is the question that you should do your own research on this particular part, and do write in the comment section that after understanding the complete flow of how ternary search will work, what do you think is the best approach to work for searching portion? Binary search or the ternary search? In other words, what do you think is the faster one? Binary search is faster or ternary search will faster? So if in future there is any kind of searching problem you are coming across, so which should be the best approach you should go for, whether it be binary search or ternary search, on the basis of whatsoever understanding you have, and give me the justification. Only answer will not work, because I want to understand your state of mind. Why you are saying any answer? When you are saying binary search, why is that so? When you are saying ternary search, why is that so? Do your own research and do let me know the answer in the comment section. I hope that the concept of how basically we can do the implementation of ternary search is pretty much clear to everyone. If you still have any sort of doubt, do let me know in the comment section. I'll see you all in my next video. Till then, bye bye everyone. Happy learning to all.